In this video, we're going to take a look at three different approaches to modeling: a fast, efficient, and an accurate modeling approach inside of Fusion 360. Hey everyone, this is Matt with Learn Everything About Design, and in this video, I want to try something a little bit different, and we're going to talk more about the overall or the overarching theme of the modeling approach of a designer. Now, I came across this idea, I came across essentially a design competition where people were modeling based on a detailed drawing, and the idea was to get the model done as quick as possible and as accurate as possible, meaning the mass of the part needed to exactly match the mass of the supplied data set. Now, this is how most of the certifications work. If you've taken any SolidWorks certifications, for example, generally what you do is you model a part, you measure the mass, and that's the answer you give on the exam. Now, the way that a lot of these work is you have to think about a couple of different aspects. One is time limit. You need to think about how quick it's going to take you to model something. The other is going to be accuracy. Make sure that all of your features exactly match what you're provided. And the other thing is efficient. And the sort of situation where you're talking about an exam, oftentimes you'll have features or details that'll get updated parametrically to change the design. Now, if you are efficient, then you can plan for those and make it very easy for you to update your design. But what I want to focus on is kind of the broader topic here of the difference between fast modeling, efficient modeling, and accurate modeling. And can we have all three of those, or can we really only have two of those at any given time? So first, I'm going to just put some basic definitions up there, what I think that each of these mean. With a fast model, I think that this is really to create a close concept model. It meets the needs, but this is not going to be a production part necessarily. Now, I know that the example here, which you can download in the description of the video, we're talking about a detailed drawing, so we already know exactly what the end design looks like. 99% of the time, you are starting with a blank slate and you have to solve a problem. So this fast modeling approach is a quick way to sort of build out a 3D model, to think about the geometry, and ultimately try to solve a problem without worrying about the constraints of things like manufacturing. Now, I do this all of the time, and I use this modeling approach to give me ideas for creating a final concept. The next option is efficient. Now, with efficient, we're talking about a part that maintains essentially a clean design history, something that can be updated easily. Now, if you know that things are going to update, things like draft angle or wall thickness, this means that you're creating parameters, you're basing your design on that. You're not exactly looking for speed here. What you're looking for is an efficient model. Now, the speed of that actually comes from making variations on your design. If you have a design where you're changing dimensions, making sure that you take the time to make sure that the design updates parametrically and is essentially efficient, then you can save time downstream by using that approach. Now, the last one is accurate. Now, the accurate approach really just means that the overall design meets all the requirements. We're talking about a detailed drawing. That's a really easy one for us to measure because we have the end result in front of us, and that's what we're trying to get to. In reality, when we're trying to problem solve and create a new concept or a new design, really what we're looking at is how well it meets the needs of the problem we're trying to solve. So you need to think about things like tolerance of the manufacturing method, tolerance stack up between parts, the assembly components, how things go together. The accuracy of all of that is a much bigger picture than just the dimensional accuracy of the 3D model. So what we're going to do is we're going to talk about these approaches and how they differ when you're starting out a new design. So I'm going to start a new blank design. We're using the metric unit system, which is what the detailed drawing is in. And I'm going to walk through a couple of different approaches for the same part. I'm not going to do this for speed necessarily, but we're going to talk about the pros and cons of these approaches. So the first approach is going to be the fast approach. Now, the fast approach for me doesn't mean spending all the time going through and making a fully defined, clean sketch with all of the features in it. What this means to me is get the model built in 3D as quick as possible and as close to accurate as possible. Now, it's not out of the ordinary to have this fast modeling approach be accurate, but it will certainly not be efficient in terms of the parametric update of the design itself. Now, when we're talking about accuracy, again, this approach I typically will use for concepts only. I won't go through this modeling approach if I have a clear end goal in sight and I know how I want the thing to be built. So to get started for something like this, I'm going to use a couple of shortcut keys. Really, all that this design needs is going to be circles and the dimensions. So by default, that's going to be C on the keyboard and D on the keyboard. Now, with Fusion 360, if you use a shortcut key for any sketch element, whether it's the line, the circle, the rectangle, or whatever, it will automatically think that you're trying to start a sketch. If you have a plane or a face selected, it will automatically start a sketch. If you don't, and I hit C on the keyboard, what it's going to want to do is ask you for a sketch plane. So hitting C, you can see the circle tool is next to the mouse, and then I can just select the plane that I want to use, and I'm already on the circle tool. Now, the dimensions are automatically being applied when I'm modeling my part, which is another thing that we want to make sure that we have turned on in the user preferences. Now, this used to be off by default. I believe it's on by default now. If yours isn't, you want to make sure that you go into user preferences if you like this approach. So the first thing I'm going to do is build out the bottom of the design, which is 125 millimeters. Instead of moving the mouse a ton to go to finish sketch or to right click and find finish sketch in here, what I'm going to do is simply hit E on the keyboard for extrude, which automatically takes the profile that I have, it selects it, and it moves into the extrude dialog. So this means I can just simply hit 10, hit enter, select the top face, C for circle, and start to draw out the next circle, which is 75 millimeters. E for extrude, select my profile. The overall height of this based on the detailed drawing is going to be 75 millimeters, but that's actually measured from the bottom of the part. So I need to subtract 10 millimeters. Now, this is where using the fast approach begins to fall apart because there is no parametric relationship between this dimension that I'm entering and the dimension on the detailed drawing. Now, in reality, to maintain sort of accuracy with the detailed drawing, what I would want to do is start from an object, select the bottom of my part, and then enter that 75 millimeters. But in this case, we're just going to accept 65 or 75 minus 10, which gives us 65. So once again, it's really quick if we just simply select a face and hit C on the keyboard. The next bit of this detailed drawing on the inside would really be best served as doing a sketch and creating a revolved cut. And there are ways that we can speed through that a little bit. But once again, just simply hitting C on the keyboard to start my sketch, entering the values. This first one is going to be 35. E for extrude, I'm going to hit minus 30. Rotate a little bit. C for a circle tool. The next one is going to be 22. E for extrude. This one's going to be minus 10, and then just keep going through this process. Now, you can do this relatively quickly if you spend a little bit of time just getting used to those shortcut keys. Where it starts to come apart is when we have a sketch like this, and you need to hold down the control key to be able to add to your selection. But then we could do minus 17. Once again, select the face. C, this one is going to be 55 millimeter diameter. And to select through, hold down the left mouse button, Control select. This one is minus 18, which should go all the way through the part. We could also select through all in the dialog, but again, when we're talking about fast modeling approach, we don't want to be moving the mouse a ton or moving the model a ton. We want to stick to things like the S shortcut key for design shortcuts, the marking menus, or by using these shortcut keys like C and E and D on the keyboard. The next thing that we need to do is we need to add the holes. Now, there are a couple ways to do this as well. You can do this using the hole tool. Now, ultimately with the hole tool, you need a sketch point or some sort of circular reference to make that quick. Now, in our case, I'm going to just use the same thing. C on the keyboard. I'm going to right click and select OK to end my circle tool. Now, if you're not familiar with the marking menu, this is a really quick way to do things. If you just hold down the right mouse button and drag, you can undo and redo, or you can go to the last command relatively quickly. Anything that you see on the right-click marking menu, especially down in the sketch section, So for example, if we wanted to add a 2-point rectangle, I would just go down and back up, and now I'm on the rectangle tool. I can right click to do undo. And again, it's just a really quick way to use those tools without having to spend a bunch of time. I'm going to select the center points of these, right click and go down to horizontal vertical, D for dimension. I need to pick the reference, and in this case on the detailed drawing, the diameter here is 55. Now if I hit 55, obviously that's not right, so I just divide it by 2, and that gives me my radius value. And then the diameter of the hole, in this case, this is actually a countersunk hole, which means that I need to spend a little bit more time. And ultimately, it's going to be quicker for me to do this with the hole tool after I have this reference. So the size of this one doesn't actually matter. I can leave it undefined or some random size, and then use the hole tool. Now, when I use the hole tool, I need to define this as a counterbore. If we look at the detailed drawing, there's actually a point at the bottom, which means there's a drill point. And then we need to enter the values. Now, there are some on-screen manipulators. If you click on these, it'll move the dialog to those different sizes. So we have an 8mm diameter for the actual hole size, 12 for the counterbore. If we select the down arrow, it goes down 25mm. And if we select this down arrow, the depth of the counterbore needs to go down a bit more. So the counterbore in this case is going to go down 10mm. So I need to enter a 10 there and hit enter. Relatively quick, the next thing that we want to do is pattern that. Now, when we pattern it, Fusion has added all of the patterns to the rectangular pattern, or basically any of the patterns can be on this pattern dialog. So it's much quicker than going down and finding pattern and going over to circular pattern, is to just select rectangular and move over here. Features, we'll select that. When you're in this dialog, there's not a real great way to tab over to the next option. So you do tend to keep the model relatively close to the dialog. Increase this to 4 based on the model, and now we've patterned that feature. The last thing that this model needs is the hole on the bottom, and then we can apply the physical material. So the hole on the bottom, this is just a through hole, and looking at the detailed drawing, it's 12mm. So once again, C, and I'm going to hit right-click marking menu, OK. I'm going to make sure that these are vertical. I'm going to use D on the keyboard to give it a value. Now the diameter of the bolt circle is 100, so we'll divide that by 2. And then we'll give it a diameter of, in this case, 12mm. Finish the sketch and we'll extrude it. I'm just going to say -10 because that's quicker than me going to the dialog and saying through all. And then I can, once again, pattern that. Now with the pattern, again, we need to go over to the dialog, pick a circular reference, and in this case, I'm going to change it to 8, and now we have the entire thing modeled. Now for the physical material, I like to do this at the top level of my component. I'm going to go into aluminum and metal and 6061 based on the detailed drawing, and then drag it over to the component. If we just drag it to the body, it's only going to apply to this body, which means if we create anything else in this design, it won't be aluminum. Then we want to take a look at the mass properties. So under the right-click menu, properties, physical, 813.633 exactly matches the detailed drawing. Of course it would, because it's exactly the same. So this model was fast, and it was also accurate. Because we had all of the ideas in place, the detailed drawing, the dimensions, we knew exactly what we wanted the model to look like. We didn't really have to worry too much about the accuracy because all of our sketches are fully defined. The only exception to that is the one sketch where we didn't really care too much about the diameter of the hole because we ended up using the hole tool. Other than that, everything else was fully defined in sketches. Now, is this an efficient way to model? We have to come back to what efficient actually means. Now, in this case, efficiency is talking about the update or the parameter-based model, which means if you had to change anything in this design, you would have to dig through all these sketches and all these features to figure out where it is. You could go to the change parameters dialog and you could expand, but you would have to go through each sketch and you'd have to find the dimension or the diameter or the distance that you need to find. And this is not a great way to go about updating a model. So That first approach is really great for concept work if you're trying to build out a 3D design and try to understand what is actually going to happen when multiple parts come together. But it's not a great way to make an efficient model. An efficient model is one that is robust in nature and can be updated relatively easily. So if we were modeling the same part and we weren't going for that fast approach, but we were looking for efficiency and accuracy, the way that I would approach that is with a revolve. Now, this means that we're going to start a sketch, we're going to start and we're going to begin by looking at this like a revolve. Again, I'm going to use some shortcuts, L for the line tool, and I'm going to begin by making a vertical line that's the overall height of my design. I then want to turn this line into a center line. Now, the reason it's a center line is important because by default, the center line is going to give us a diameter dimension. And when we create a revolve, it's going to use that center line as the revolve axis automatically. So that does help us a little bit with the accuracy and also the efficiency of the model. The next thing I'm going to do is use the line tool to build out the rest of the design. Now, using these endpoints as my reference, I'm just going to start to rough the design out. I'm not going to add my dimensions yet. That green check mark always seems to be in the wrong place, so I'm going to go ahead and come over, come up to the top, over, down, over here. Again, that green check mark is in the wrong place. Then I'm going to hit escape. Now that I have this roughed out, I want to make sure that that line is horizontal. And I need to make sure that the overall height of this is referencing my construction line. So the top edge is going to be coincident with this point, and this bottom edge coincident with this point. So now the overall height of the design is locked in at those values. The next thing that we want to do is we want to begin dimensioning it to the various diameters that we have. So starting from the center line, going to this midpoint here, you can see that we have a diameter value of 37.9 and some change. This is going to be 22. Then I'm going to come up to the top. I'm going to do the same thing over here. This is a diameter of 35. Now I'm going to work my way down. This is going to be a diameter value of 35 as well. And this last one here, this is going to be a diameter of 55. So this is building out the model based on the detailed drawing. We're going to give these overall heights. This one will be 18. This one will be 17. This one will be 10. And when I do something like this, I try to make sure that all of the dimensions are there. So this last one isn't needed to define the part, but I'm going to create a driven dimension to just validate that it's 30 millimeters as it should be in our detailed drawing. The next thing we're going to do is we're going to dimension the overall outside diameter. Now this portion of the design, this overall width, is going to be 75 millimeters. And then the last piece of this puzzle is that bottom flange, 125 and 10 millimeters tall. And once again, the overall height is 75. I'm going to move this over here just so we can see it. So we have 75 millimeters tall, 10 millimeter for the flange. We have all of the inside dimensions for the diameters, the IDs, and we have each of these heights. And these are all based on the way the detailed drawing is laid out. You can always drive this through different dimensions. The overall height of this is driven off the 75. So for example, if I say 85, we can see that this 40 here is different. If I say 65, again, it's 10 millimeters off. So this helps us when we're talking about making an efficient and an accurate design. It's accurate in the fact that we're matching all the dimensions we need, and it's efficient because all of the information that we need in order to create the references, they're all here in this sketch. Now, there's a couple of other things that we can add to this sketch as well. I'm going to add 2 lines. Now this one's not going to be at the midpoint. I want to make sure it's off to the right a little bit. I'm going to say okay. I'm going to do the same thing down here, making sure that I'm not at the midpoint. Now, the reason I want to add these lines is because I'm going to give a bolt circle center reference. So this one here is going to be 55 millimeters, which likely is the midpoint there, but we don't want to automatically assume that's the case. And this one down here, the bolt center is going to be 100. Now, these are not needed, so I'm going to convert them to construction using X on the keyboard. And that will give us a reference for where those bolt holes need to be. Because in the detailed drawing, we have a pattern of 4 and 8, which means that on this plane, we can put a bolt reference right there. So once again, everything is in this initial sketch and we can drive all the information there. When we select revolve, again, because we used a center line inside of our sketch, it automatically grabs the profile, automatically grabs the revolve. It's set to a partial for 360. That doesn't really matter because it's going all the way around, but I'm going to change it to full and say okay. Once again, everything we need is back in that original sketch. I'm going to show the sketch. I'm going to use the hole tool. I'm going to select this point and notice that the orientation isn't correct. So the way that we can get around this is we can place it on the top and then we can move it and snap it to that point. Now, if that doesn't work, oftentimes what it means is that sketch reference is not in the right place. It's not going to allow us to use that without this option. But we do have this reference, and when we select a reference inside of here, we can grab references of edges to place it, but we can't grab these points unless we're using the multiple sketch point option. And that sketch point needs to be normal to whatever sketch plane it is. So in order to use that data that we've already built in here, we can start a new sketch on this top face, and we can use our project tool to bring that endpoint using P on the keyboard, and we can bring that into the sketch. I'm going to do the same thing down here while we're doing it. I'm going to rotate it slightly so we can see it. I'm going to grab that endpoint, hit P on the keyboard using my project tool, and finish the sketch. Another thing about efficient modeling is making sure that we name our sketches and features, because if we come back here, we want to make sure we know what we need to edit. Now, sketch 2 and sketch 3 don't actually matter because the profile sketch controls those hole locations. These are just projected, so I'm just going to call this top hole PROJ for project, and I'm going to call this one bottom hole PROJ for project. So that way I can kind of remember their projected references. If I happen to show the dimensions in this original sketch just for reference, and I change this to 65, the line is going to move, and so is the projected point. If I change it back to 55, you can see it moves back. You'll notice that this sketch is listed as underdefined, and that's because these construction lines can still move around, but their endpoints are still fixed at this location. So the fact that these lines can extend doesn't really matter. If that happens to bother you, you can always go back and give them a dimension, give them an equal constraint to something else. In this case, again, we don't need them, so I don't really worry about making sure those are fully defined as long as I understand the implications of all the rest. Now when I use the hole tool, I can select that as my reference because now we are normal to the sketch plane that was created on. This already saved all the information from the hole from the last time we used it. If it didn't, then we would be able to go ahead and place it in there. Now you will notice that in this case, I didn't create all the points for that in that sketch. I could have patterned it, but it's probably better for me to use the feature pattern here because everything in terms of our references are all on that sketch plane. I can select an axis of rotation. Whenever I'm doing this, I like to use the Z-axis if possible, as opposed to geometry when I'm talking about an efficient approach, because I know the Z-axis isn't going to change. Next, we can use the hole tool. This time we're creating a simple hole, and it's going to be through all. The placement is going to be based on that point. The diameter is 12 millimeters, and I'm going to just select through all for my distance. Now, the reason I like to use the hole tool even for that simple hole is because there's metadata that's associated with it. This means that when I'm inside of a detailed drawing, when I select that hole, it's automatically going to know it's a 12 millimeter hole. It's going to know exactly all the details about it. Now, that makes more sense when you have something like a tapped hole, or if you have a counterbore like this, that information automatically gets populated in a detailed drawing. The last thing we need to do here is, again, the physical material. We need aluminum 6061. And once again, just like before, I'm going to apply it to the component level, not the body on the screen. And then we can double check our mass properties. There shouldn't be any difference between this and the last example, 813.633. So you can see they're both exactly identical. So at the end of the day, really the main difference that we have here is going to be in the number of sketches, the number of features that get created, and those references. So the references are the important bit. Even though we've got 2 additional sketches here, those sketches are projected references from the original. Everything that we need in order to modify this design is contained in that first original sketch. All the detailed dimensions, all the references for the bolt hole locations, everything happens in that profile sketch. This means that this design is extremely efficient when we get to making updates for it downstream. So the two approaches we looked at were fast and accurate because we were looking at a detailed drawing. We had all the dimensions we needed. And the other was efficient and accurate. Now, each of those took a look at two out of the three topics, fast, efficient, and accurate. Do we have a way that we could be fast, efficient, and accurate all at the same time? Well, the answer to that is yes, but there's not some magic modeling approach that makes that happen. The only way that happens is if you are efficient with the tool. So in order to get a fast modeling approach that is also efficient and also accurate, the main way that I found to do that is to get comfortable with things like shortcut keys, customize the user environment so that it works for what you're doing, and just be able to apply the tools in a quick manner. There are things in Fusion 360 that do slightly prevent that from happening. So, for example, when you're in a dialogue and you're placing a feature, when you have a dimension dialog and you hit tab, it will go to the next dimension dialog. And this is universally true across Fusion. Whenever you're in a dialog that has a dimension input box, you can tab to the next one. However, when you're in a feature, let's say that you're in a revolve or a sweep where you have a profile and then you want to tab over to select the axis of revolution, that doesn't work. You can't tab over to get that. And unfortunately, that just means that there's not a quick way to apply some of those tools. There are instances where things like using a centerline sketch inside of a profile that you're creating will automatically grab the profile and the center line axis for the revolve. That's not true for things like lofts and sweeps, but it does work for certain tools like revolve. There are other things to know, like hitting C on the keyboard to start a circle tool, especially when you have a face selected, will automatically start that new sketch. Getting comfortable with the right-click marking menu. These are things that can make the modeling approach extremely efficient because it's going to be contextual. So by default, you can see we've got things like extrude and fillet on here. If I select a face and right click, only the things that are applicable to what I have selected will show up in this menu. Create a new sketch because it's a planar face, extrude that face, create an offset plane, or shell the feature. If I select an edge instead, right click, I can create a fillet or a chamfer. If I have multiple selections, for example, 2 edges, I can still do a fillet and a chamfer. Now I can create a group. We also, if we select a face in that, you'll notice that we have some options: extrude, fillet, chamfer, shell. This means that if we select extrude, it's going to drop off the edges. If we select fillet, it might be able to use the face and the edges. If we select chamfer, it'll drop the face and so on. Shell will drop the edges. So there are cases where understanding what tools will be available to you as soon as you use things like the right-click marking menu are going to be very helpful to being efficient and fast. The S shortcut key, this is another one that's extremely helpful because even if you don't have things on the shortcut menu here, the look at, the zoom to window, and the shell, these are things that pop up on our right-click menu: extrude, fillet, look at, zoom, window, and shell. Now, if you don't have these on your S key menu, if shell isn't there, for example, if we go down to the shell tool, if I go and take it off of my shortcuts, now it's not there anymore, which means it's not on my right-click menu anymore. So anytime that you have a tool that you use constantly and you don't want to go from the middle of your screen all the way to the top or over to the right, you can pin it to that shortcut, or you can use S and just instantly start searching for it. Now this allows you to get to the whole tool pretty quickly without ever leaving the keyboard, which means that the mouse doesn't need to go up here and go down. Now that might seem a little silly, but if you work in a professional environment and both speed and efficiency are key, then little things like that, keeping you from moving your mouse to the top left, to the all the way to the right, to the model, and making these selections, it does add up and it does make you quite a bit more efficient. So I think the takeaway here is that you can have two out of the three modeling approaches between fast, efficient, and accurate, no matter what your level of comfort or proficiency is with the software. But in order to get all three of those, you really need to be comfortable with whatever CAD program you're using and whatever devices that you're using to control them. Things like 3D mice or the type of mouse that you're using, the keyboard shortcuts. You need to spend a little bit of time and get comfortable with those, setting up your user environment to customize them. The last thing that I want to take away from this video is going to be customizing the UI just a little bit. Now, there's not a ton that we can do in Fusion 360, but there are a few things. We've already taken a look at the option to pin to the shortcuts. We can also pin things and remove things from the toolbar, and we have a change keyboard shortcuts option. Now, this is on a per feature basis. Now, what that means is that you need to find the feature you want the shortcut for. So for example, extrude. If you don't like extrude being E, you can go in and change the keyboard shortcut. So those keyboard shortcuts are a quick way for you to make changes. Now, I don't generally change my keyboard shortcuts. I used to do this quite a bit when I worked in SolidWorks in a more professional capacity. But since I create a lot of video content for Fusion, I tend to leave all of my stuff as default, including anything that changes with the UI updates. With that said, anytime you go to your menus, you can see very easily what those shortcuts are. Some shortcuts are more helpful than others. E for extrude is extremely handy. When we go to the modify panel, Q for press pull and F for fillet, M for move copy, I use those all the time, as well as A for appearance and delete. Those are features or shortcut keys that I am constantly using. Another one that I tend to use quite a bit is when I select things inside the browser, V is the shortcut for visibility. So instead of right-clicking, going to show hide, I just hit V on the keyboard, and that allows me to show and hide things relatively quickly, whether it's a grouping of selected components or features or bodies or sketches. That lets me do that quite a bit quicker than if I had to click the icon next to each one or right click and find show hide. So those are very handy, and just getting comfortable with a couple of those is helpful. The other things that are pretty handy are going to be some of the shortcuts for sketching. Things like L for line, C for circle, R for rectangle. Those come up quite a bit. Now, generally I find that I use a center rectangle more than a 2-point, which means that when I hit R, I'm going to have to go over here and make it a center rectangle. If I was doing a lot of modeling in Fusion 360 for a professional capacity besides creating training content, I would likely change that rectangle to a center point rectangle for the shortcut key. That's just my sort of preference. I used to use splines and surfaces quite a bit, so I would have the spline as a shortcut key. I used to use P on the keyboard for that because P is the project command in Fusion, which again, I use that one quite a bit. I don't tend to do a lot of fillets and sketches or chamfers, so I don't really use those. Trim and offset I don't really use, but I do use move copy quite a bit. So getting comfortable with these different shortcuts can speed up your modeling approach. The main thing that you need to focus on is not moving the mouse around quite as much and being efficient with your selections. Things like selecting a face, then if you're going to create a circle or a rectangle, just hit that shortcut key. Save yourself the time from going up here, starting a new sketch, selecting a face, finding the tool you want, and coming back down. All of that time adds up quite a bit. Now, again, it might seem silly, but it does tend to add up quite a bit, and you can get a lot more done over the course of a day or week or a month. It really does add up quite a bit of modeling time. So if you're doing this day in and day out, those little seconds here and there can equate to quite a bit more time on working on your designs. I think that's about as far as I'm going to take this. I didn't intend for this to be over a 30-minute video, but at this point, if you have any questions, please let me know. As always, thanks for watching, and we'll see you in the next one.